Okay, so what I've got for you here, I'm going to show you a couple of things. I'm going to show you how to plot a linear equation. And in addition to that, you need to actually understand how to set up your Cartesian plane the right way as well. So we're going to follow the steps in this question, and hopefully we'll come up with a brilliant answer. This looks quite innocent, but I guess the person that wrote this had ulterior ideas in mind, and that's why they've kind of left this blank, hoping that the people looking at this question might actually take a different approach to this. Because usually when you see a table of values, you might just put like -3, -2, -1, 1, 2, 3, or maybe you might do -5, -5 on the other sides, -5 to +5. It's up to you when you're doing a table of values, because at the end of the day, you've got to plot this line. I'm taking a look at the equation and I see that I'm going to have to divide whatever I've got by 5, and you know I've got 4 as the coefficient of this x, so I'm going to want to have some type of a number that's got a factor of 5 in there, or is going to be easy to deal with when I multiply it by 4 and divide it by 5. So maybe I'm cheating a little bit, maybe not. I'm going to use -5. I'm going to use -2.5. I'm going to use 2.5. I'm going to use 5, and I'm going to use 7.5, and I guess 7.5 on the other end. But I'm not even going to bother with some of these, because when you do a table of values on a linear equation, what happens is there's a pattern, and as soon as you identify the pattern, everything's all good, and we're moving ahead. It's got 0 here, nice and easy in the middle, and if we let x equal 0, all we do is we cover up this whole product of x, and we get y equals -1. So we don't even have to do any working to actually show that result. For the other ones, we actually have to sub that value of x into the equation. So I'm just going to call it a function, and have it, so the function of x is equal to -4x over 5 minus 1, and now I'm going to just start substituting values in. I don't have to do it in any particular order, but I think I might start at the -5 and work my way across. As soon as I see the pattern, I'll be able to fill in the blanks. So let's do the function of -5. What that means is I'm replacing our -5 over here. I'm replacing our x with -5, I should say. And you'll see very soon, if you haven't already worked out why I chose 5, because I can just do this, and I've got 2 negatives here. So my next line just becomes 4 take away 1, which is equal to 3. And this way I'm not having any fractional type answers with these points, which are going to be really hard to actually judge when I come over to this Cartesian plane. So I've got a couple of values in here. Because it's linear, I can probably already tell that this value is going to be 1, and the step is going to be 2 between each of the values that I've chosen. But let's just be safe, and we'll do another one just to help with our communication as well. So I'm going to substitute in the value -2x this time around. So I've got -4, and let's just put in a different color. I'm just substituting in -2.5 for x, dividing this by 5, and then I've got to remember to take away the 1. So I've got -4, the negatives are going to cancel, I don't have to worry about those ones. I've got 4 times 2.5, 4 lots 2.5 is 10, 10 divided by 5 is 2, take away 1, and here's the value that I was looking for. There's my 1. I've at least shown a bit of working, there to make sure whoever's looking at this later on can see where I'm getting these ideas from. If I wanted to be thorough, I could go ahead and do another one of these, but it's quite clear that the pattern follows here, and I'm jumping by 2 on this scale that I've chosen. So by design, I've made this really easy for myself, which initially, if I hadn't really taken too much thought in preparing myself to do this table of values, this could have ended up a lot messier and a lot harder to graph. So I've done my table of values. I need to prepare my Cartesian plane. These are the things you need to make sure you do whenever you prepare yourself a Cartesian plane. We've got 2 number lines. So number lines go on forever in the directions that they're pointing. This number line needs a label, so it's going to be my x. This number line needs a value, so it's going to be my y. It's now officially a Cartesian plane lacking a scale. So the next thing I need is a scale because I have to plot these points. I can see that I'm going to need, based on the grid paper here, I might not even plot these last 2 points on the end here. I'm just going to go with, again, maybe I'm cheating. I'm going to put -5 there. And I'm going to put 5 there. I can choose a different scale for my vertical axis as long as it is linear, as in each section has the same gap between each one. But if you see here, my highest y value is 5, my lowest y value is -7, which should work out well from here. So 1, 2, 3, 4, 5. This is going to be my +5, and 1, 2, 3, 4, 5. This is going to be my -5. Okay, so now that I've included the scale, it's going to be something that I can deal with, and I can start plotting everything that I need to on here. I've prepared my Cartesian plane. Plot the points of the values. So when x is -7, it's kind of off the page there, so I'm a little bit naughty. I won't be able to fit those ones on, but maybe if the graph paper was a little bit more kind to me, I could go ahead with that. Probably not an excuse in an exam, but in a little demonstration, no problem here. So here's my first point, -5, 3. So here's -5 and up 3. Let's choose a different color so it stands out. There we go, there's our first point, we've plotted it. The next point here is -2.5, 1. So -2.5, 1. There's our next point there. Our next point is 0, -1. So 0, -1. Then we've got +2.5, -3. We've got 5, -5, which will be that point there. So there you go, I've gone ahead and I've plotted those points from my table of values. The next thing I need to do is I need to sketch and label this equation. So I'll make sure that my points are nicely lined up. I go through each of those little crosshairs between on the graph paper. I make sure I draw my, again, this is another continuous line. So I do mark that it goes on forever in both directions. And I do need to label that this is y equals -4x on 5, take away 1. I've sketched, I've labeled the equation. It goes on forever in both directions. I've done point 4 on our list. The next little one, one of these is going to be easy, the other one's going to be a little bit harder, but we can play around with it. We need to calculate and label the x and y intercepts. I was very keen to tick that off then, but I can't quite do it yet. I've already got one. I worked out when I got rid of this whole little product at the front here, I've just got y equals -1. So that's this point here, and I can go ahead and label this straight away. When x is 0, y equals -1. I can kind of have a look here at what this y-intercept is, but I do need to go and actually calculate that. So that's the next step. Again, no way of getting out of it this time. I have to go through the nitty-gritty. So here's y equals -4x over 5, take away 1. And what I want to try to work out here is I want to know what x equals when y equals 0. So let y equal 0. 0 is equal to -4x on 5, take away 1. A little bit of algebra, I can flip this across to the other side, change the sign, equals -1. I'm going to multiply this side by 5, which means I multiply this side here by 5. So 4x would equal -5. And now I'm just going to divide this by 4, which means I divide this by 4 on this side here. And you can see here that x value is equal to -5 on 4, or -1.25. Which you probably could have worked out from this table of values up here. You can probably see that halfway between these 2 points is the 0 for the y value, and therefore halfway between these points would be -1.25. But now that we've actually shown it algebraically, thumbs up, we're looking good. So I will just mark this point here, and then I just need to label it. So when x is negative 1 1/4, y is 0. I've calculated and I've labeled the x and y axis. I've filled in my table of values. I did a couple of practice substitutions to make sure I knew what my pattern was and that I could work it out. I plotted each of my points along the line here. I've drawn my line. I've set up my Cartesian plane. I'm finished. I'm done.